In this video, I'll explain how bias differs from error. To do so, I'll use a visual example. Let's imagine you have a shooting gallery visited by 3 archers. Each archer takes 4 shots. It is clear that Archer A is the most accurate, because each of her shots are grouped around the bullseye. The shots are clustered around too closely to be the result of chance, and each arrow hits the intended target. Archer B provides a demonstration of error. His shots seem random, they are spread widely apart. Although one shot is close to the bullseye, that seems to be more out of luck than skill. His shots are random, not systematic. Archer C is a demonstration of what we really care about here: bias. Do you see how the shots are grouped? This is not an indication of a lack of skill nor a random error. The archer knows the mechanics of the aim, but something is preventing them from focusing their skill on the correct target. Perhaps they cannot see the target properly, or the bow is too heavy. In any case, something stronger than simply repeated practice is necessary to hit the target correctly. This is a visual analogy to the difference between a random error and bias, which is systemic. You see, Archer B makes a lot of errors, but with enough practice, they will know how to hold the bow, how to aim, and how to shoot to hit the bullseye. But Archer C doesn't lack skill, but they cannot see the target correctly either. So practice will not solve the issue, because bias is a systemic error, not a random error. If we make random mistakes, we're able to do the task again and make corrections, or ask others to double check for us. The idea is that if you check your work, you'll be able to spot and correct the error. However, if your judgment and your decision is fraught with bias, then the bias is likely to go unnoticed and uncorrected. No matter how many times we go over it, or how much advice and supervision we get, we won't be able to spot the bias unless we or our advisors are trained in bias spotting. There are 2 types of techniques that can help you mitigate bias. The first one requires the decision maker to eradicate bias via deeper thinking and engagement of their system too. We call this approach debiasing, via anti-bias strategies which you will learn in our unconscious bias course. This is like the archer learning to lift their bias glasses so that they can see the target correctly. The second technique aims at improving accuracy, not by improving the shot, but by moving the target so that the shot will look more accurate. This means that the work does not involve extra thinking from the decision maker, but requires the intervention from someone external. This could be, for example, colleagues who change the decision environment for you. Let's say you have a tricky problem to solve, but because of either-or fallacy, you reduce your problem to 2 solutions. Option A, okayish, and option B, never ever. Both solutions aren't good decisions, but because of your bias, you cannot see any other way. Then, it might actually help to change your decision environment by asking colleagues who have a very little in common with you. Diversity is crucial here, because a diverse group of advisors look at a problem from different perspectives than you. Now, you can still have bias and only see option A and option B, but your colleagues help you externally and show you options C, D, and now E. This is called decision architecture. You as the decision maker didn't have to think harder, but something external, in this case your diverse group of advisors, made it easier for you to make the right decision and hit that bullseye. Whichever technique you use, this video showed you that it is important to spot and mitigate bias, because it will not simply just disappear just by trying the task again and again. That's what makes bias different from random error.